Welcome to This Explainer. Today, we are diving into the ultimate story of expanding horizons. We're going to explore Stephen Hawking's absolutely incredible journey, from severe physical limitations to uncovering the deepest, most profound secrets of the cosmos. If you want to understand how one brilliantly unconventional mind forever changed our view of space, time, and existence itself, well, you are in exactly the right place.
Here's a quick roadmap of what we're covering today. First up, a mind without limits. Then, rewriting the rules of space-time, followed by bets, books, and pop culture. After that, we'll get into the mind of the cosmos, and finally, a legacy among the stars. Let's get right into it.
Section 1. A Mind Without Limits, The Man and the Diagnosis. We're starting off at Cambridge University back in 1963. This was a massive turning point, where a totally devastating medical diagnosis threatened to stop a once-in-a-generation mind right in its tracks. Imagine being just 21 years old and receiving a diagnosis of ALS, along with a life expectancy of just 2 to 3 years. It's almost unthinkable, right? But Hawking's physical ordeal created this powerful contrast with his sheer will to survive. As the progressive neuromuscular disease took its toll, his assistive technology had to constantly evolve. He went from using walking sticks to a motorized wheelchair in the 70s. Then, in 1985, a life-saving tracheotomy permanently severed his vocal cords, which led him to use the famous Equalizer software. Eventually, by the 2000s, having lost all hand movement, he was actually navigating the software using an infrared sensor on his glasses. It literally detected microscopic contractions in his right cheek muscle. Just incredible. Now, as you might expect, that initial 2-year prognosis threw Hawking into a severe clinical depression, but a profound realization really changed everything for him. While he was in the hospital, he witnessed the rapid, fatal progression of leukemia in a fellow patient. And seeing that provided him with a much broader perspective on human suffering. That sobering realization, combined with his recent engagement to Jane Wilde, ultimately gave him the vital, urgent purpose he needed to get back to work and finish his PhD.
Moving on to Section 2, Rewriting Rules of Spacetime, the Physics. Once Hawking got back to work, theoretical physics would literally never be the same.
Working alongside physicist Roger Penrose between 1965 and 1970, Hawking formulated the legendary singularity theorems. Using some seriously complex geometry applied to expanding spacetime, they mathematically proved a profound sequence of events. Basically, if general relativity is universally valid, and matter behaves normally, then spacetime absolutely must originate from an initial singularity of infinite density and curvature. So what does this actually mean for us? It means they proved mathematically that the universe had a definitive temporal beginning at the Big Bang. It didn't just exist forever, it started somewhere. Let's talk about the Bekenstein-Hawking entropy formula. This equation is an absolute masterclass in theoretical integration. It brilliantly bridges the physics of the extremely small, quantum mechanics, with the physics of the incredibly massive, general relativity. And it does all of this while factoring in thermodynamics and the speed of light. Hawking drew these deep mathematical parallels between classical thermodynamics and black hole mechanics. He proved that the entropy, or the fundamental disorder, of a black hole is directly proportional to the surface area of its event horizon.
But he definitely didn't stop there. In 1974, he published a paper that completely shocked the global physics community: Hawking radiation. By looking at the chaotic quantum physics right at the edge of a black hole, he discovered that tiny pairs of particles constantly pop into existence, and some actually escape into space. This staggering discovery completely overturned the classical consensus that black holes were purely absorptive traps that nothing could escape from. Because of this thermal emission, black holes slowly lose mass energy, and eventually, over just unfathomable timescales, they evaporate and explode.
Section 3. Bets, books, and pop culture, humanizing the genius. It is so crucial to remember that Hawking wasn't just some distant, unapproachable genius trapped in an ivory tower. He was a massive pop culture icon with a fiercely playful nature.
He absolutely loved making bets with his colleagues. He'd routinely wager with physicists like Kip Thorne and John Preskill on major open questions, betting things like magazine subscriptions or a baseball encyclopedia on whether Cygnus X1 was actually a black hole or if the Higgs boson would ever be detected. This really highlights his intellectual humility and scientific integrity. He used these highly public wagers to test his hypotheses, and he always openly and graciously conceded when empirical evidence or new math proved him wrong. Beyond academia, his massive cultural footprint completely reshaped how the public engages with science. His 1988 book, A Brief History of Time, was an unprecedented phenomenon. It made abstract ideas incredibly accessible and sold over 10 million copies. He enthusiastically embraced pop culture too. He played poker with Einstein and Newton on Star Trek and guest starred on The Simpsons and Futurama. He even co-authored children's books with his daughter. And I just love this. He steadfastly refused to upgrade his famous, slightly American-accented robotic voice to a smoother, more modern alternative. He fiercely protected it because it was a core part of his identity.
Section 4. The Mind of the Cosmos. Philosophy and Realism. So, how did this deep, mathematical understanding of quantum gravity shape his broader philosophical views on reality and existence?
Well, Hawking's philosophy was deeply tied to his physics. He was grounded in a concept called model-dependent realism, which he detailed in his book, The Grand Design. Essentially, he argued that we don't just objectively experience reality exactly as it is. Instead, our minds interpret the cosmos through conceptual models, math, and our sensory filters. For Hawking, any theoretical model is completely valid as long as it accurately accounts for observational data without adding a bunch of unnecessary complications.
And it's really interesting to neutrally observe how this framework influenced his views on the ultimate origins of the universe. Over his lifetime, his philosophical stance evolved quite a bit. Early on, he suggested that a creator was compatible with theoretical physics, maybe as the entity that just set up the initial boundary conditions. But as he and James Hartle developed the no-boundary proposal, which suggests the universe is finite but has no edges, his stance shifted. He concluded that because of laws like gravity, physical spacetime spontaneously creates itself. This moved him to an explicitly atheistic position, stating that his mathematical models made a divine creator scientifically redundant.
Which brings us to Section 5, A Legacy Among the Stars, Final Impact. As we reach the conclusion of his remarkable life, let's look at the lasting mark he left on our world.
55. Just think about that number for a second. Despite receiving that grim 2 to 3 year life expectancy at age 21, Hawking survived an unprecedented 55 years post-diagnosis. Because his specific variant of ALS progressed so slowly, he had the time to completely reshape cosmology. He did this by focusing his energy entirely on his capable domains, physics, math, and writing. These were the areas where his brilliant intellect was completely untouched by his physical limitations.
His institutional and cultural legacy is truly monumental. Today, his ashes rest in Westminster Abbey, directly between history's absolute scientific giants, Sir Isaac Newton and Charles Darwin. But his legacy is so much more than history. He founded the Center for Theoretical Cosmology at Cambridge, established a Medals for Science Communication, and all of his incredible physical artifacts are permanently preserved. Crucially, he also used his final years to warn us, challenging humanity to wake up and prepare for massive existential threats like climate change and uncontrolled artificial intelligence.
Hawking believed spontaneous creation explains why we exist. But the question he continually posed to us all was, what are we actually going to do with that existence? He leveraged his massive platform to push for space colonization as an insurance policy for humanity. He was constantly urging us to be adaptable, to safeguard our planet, and above all, to remain relentlessly curious about our collective future.
Take this final, provocative directive, which is actually inscribed right on his memorial stone at Cambridge. As a lifelong challenge for yourself, remember to look up at the stars and not down at your feet. What models are you using to interpret your reality? Are you willing to concede your assumptions when the facts prove you wrong? Stephen Hawking's life proves beyond a doubt that the human mind can transcend immense physical boundaries to understand the very fabric of the cosmos. So I leave you with his ultimate challenge. Embrace your curiosity, question the dogma around you, and never, ever stop wondering about your place in this magnificent universe.